Welcome to the introduction to Lean, Six Sigma, and Operational Excellence, sponsored by Caldwell's and Associates. We are a licensed Shingo Institute affiliate. We specialize in two areas. One is operational excellence through the Shingo Model, which we're going to talk about here in this training class. And we specialize in critical business problem solving. Both we provide consulting and training. Training, we have standardized classes and we can customize classes to your company's needs. And we provide technical coaching in Lean Six Sigma and Black Belt. We also provide yellow belt, white belt, and green belt. Our experience covers many industries: automotive, aerospace, food processing, medical devices, pharmaceutical, warehousing. Our team is made up of 3 Lean Six Sigma Master Black Belts, independent contractors working together through Caldwell's and Associates. First, we have Greg Battles. Greg has had over 30 years. All 3 of us had over 30 years of experience. Greg has worked at GE and Ford, and at Ford where he worked 2 years, and in Ford production system in Tokyo, Japan. Also, we have Dr. Andrew Lux, and Andrew has intensive experience in Class 2 and Class 3 medical device and pharmaceutical manufacturing companies where he's led business transformations and turnarounds. He's also worked in companies like GE also, and Johnson & Johnson and Medtronics. And then we have myself, R.C. Caldwell. Have over 30 years like my colleagues. I've worked at GM, Goodrich Aerospace, and Johnson & Johnson. Johnson & Johnson was my last employer where I had opportunity to lead a global team, partner development, supplier excellence team that had master black belts, and Lean Sensei that went into our suppliers and our supply chain and help them with critical business problem solving and also help them with operational excellence. So now we get into our agenda. We're going to have a brief history of operational excellence. Then we're going to talk about what is Lean. And under what is Lean, we're going to first start with what Lean is not. Then we're going to give a definition of Lean. Then we're going to talk about Lean culture and what it is. And then we're going to talk about the tools, with some of the tools that's within the Lean culture. And then that's going to take us to what is Six Sigma. Simplified version, we're going to give a definition of Lean Six Sigma and why it's a function of X. I'm going to explain the meaning of that and how Six Sigma impact quality, and really true important of the Six Sigma tool. Then we're going to look at what is operational excellence. We're going to define operational excellence. We're going to also, I'm going to go over basic building blocks to operational excellence and how to achieve operational excellence through the Shingo model. The Shingo model is there's other things out there, but this one is a great model for continuously having excellence in your organization, whether it's manufacturing or hospital or service or nonprofit. Then I'll give you some examples of some operational excellence companies. So let's start with the history. It starts back with Frank and Lillian Gilbert, a bricklaying. He came up with an easy way for bricklayers to a bricklaying system that is still used today to build complexes, buildings and homes and etc. Then we go to Henry Ford. He developed, he introduced assembly line production. Prior to that, automobiles were built in one spot, where parts and people were brought to that one spot and completely built it. And he came up with the assembly line, which revolutionized automobile making in a lot of other industries. And from there, Deming, Dr. Edward Deming, tried to get, after the war, tried to get American companies to go buy into his total quality management, but they wouldn't. So he went over to Japan and helped companies like Toyota understand quality, because prior to him helping them, I can remember Japanese cars when I was a young kid. Japanese cars, we call them rust buckets on wheels, and they didn't last. That's why you don't see us. You can see a 64 Chevy. You can't see a 64 Toyota because of that. But not as common. So, when Dr. Deming went over there, he gave them a total quality management system. They implemented that. Plus, they had Dr. Shingo that helped Tuichi Ono come up with ways to improve the Toyota production system. And Shingo's one of his, in my opinion, his biggest contribution was single minute exchange die, SMID, where you can do quick changeovers, which allowed you to do different color cars quicker and more efficient with less time and smart, not just doing it fast, but doing it quick. So it would be easy for the operators. That's a big difference in that. So he did a very good job in that. And in 1973, when we had the oil crisis, that allowed Americans to go to smaller cars. They found out the Japanese cars were better quality, more fuel efficient, and that's how it was introduced through the oil crisis. And from there, people started investigating the Toyota production system. And then in the 80s, Elliot Goldratt came up with this book called The Goal, which talked about bottlenecks. It was useful in operational excellence. And in 1986, Motorola at the time were making beepers, and they were making millions of beepers. So if they had 3% bad and you're making a million, that's 30,000 parts that are bad. So they had to go something higher than 3%. So that's when they came up with Six Sigma, which means 3 parts bad per million. And also in the 80s, we had Shingo gave its first Shingo Prize. The Shingo Institute, that's one of the things that they do, is provide the Shingo Prize to companies that exhibit all these techniques and tools at that time of Lean and Six Sigma. So the Global Metallurgical was the first company in 1989 to receive the Shingo Prize. Then Jim Womack and Daniel Jones wrote 2 books. The first one was A Machine to Change the World, which both books, what they did was they examined the Toyota production system and said, well, what's the difference? What is it different to, and what are the techniques and the things that's involved, and how it compared to the to the American system, the Fords and Chrysler. And they came up with these 2 books, and they called the lean manufacturing. That's where they coined the term lean manufacturing, and that's where it came in, which is essentially at the time was Toyota production system. Then in the 2000s, the Shingo Institute eventually changed the Shingo Prize and made it more robust, and started looking at the culture and came up with this operational excellence, Shingo Prize for operational excellence in 2008. Then later on, a book that was written called The Lean CEO talked about world-class excellence. which is still part of the operational excellence. And now today we got COVID-19, which we need to adjust our Lean Six Sigma techniques to embrace COVID-19 and make sure that our operators are safe. And that's where we are today until we get a cure for COVID-19. And once we get a cure, then we can go back to the traditional operational excellence improvement and Lean Six Sigma improvement. Now, what is Lean? Start with what Lean is not. Lean is not making your workers work harder or faster to get a task done. That is not Lean. Lean is the opposite. It's making your job easier so that your worker can get it done more efficient and faster that way by making it easier. So if you make it easier, they're going to get it done faster, which is a win-win for everyone. And it's not about cost improvement. I've seen where you go, you can sub-optimize if you're just looking at cost. Because some places where you might have a cost improvement upstream, like in receiving or at your supplier, it might cost you more downstream. So you want to look at the total value stream. And that's look at the definition, beginning with design, then extending into the factory and ending with the customer. Lean is the process of removing waste from all aspects of the business enterprise. So if we look closer, we have beginning with design, extending into the factory. That's the total value stream all the way to the customer. That's from birth to the end of the product cycle to the customer. Okay? So, and how the customer felt about it. Then add on Lean is the process of removing waste from all aspects of the business enterprise. That is everyone, because one person can't do that. You can't just hire a Lean expert and say, hey, let's do Lean. You're only going to be doing just a little, you're not even going to scratch the surface with a one-man band. Okay, so the thing you want is you want to understand you're going to bring in this Lean culture because it's really a foundation to this operational excellence. It's a Lean culture. The Lean culture is about making everyone more or less a Lean thinker. Okay, now you may not get 100%, but if you get 80 to 90%, the other 20 to 10% is going to just come on board with it. And it's a positive culture. You know, it's a high-performing culture. If you ever seen a Lean culture, it's a self-driven teams, okay? Self-directed teams. And everybody buy in. Like I said before, 80 to 90% is a good number, all right? And it's a winning culture. And within the culture, you're going to use these Lean tools, methodologies, and principles and concepts, and you're going to pull them out when you need them. All right. But the thrust of it is having people think Lean. Here's some example of some Lean tools: identifying and eliminating waste. All right. And one of them is unnecessary motion. If you're doing some unnecessary hands off and more steps than needed, even in transactional work, you got people making redundant spreadsheets. You want to eliminate that. Okay, that's unnecessary motion. Waiting. Anytime you're waiting for stuff, that's the area that you want to look at to identify and eliminate. Excessive inventory is another area. Too much inventory. I mean, how many times are you in the food industry, obsolescence due to spoilage gets too old? And you see obsolescence even in automobile, building too much inventory, excessive inventory, and excessive transportation. All these moves back and forth from one side of the plant to the other side of the plant. Defects you definitely want to get rid of. You want to be Six Sigma quality. Six Sigma quality. You know what Six Sigma quality is now. And over processing, if you know, doing something that's not necessary to get the job done and get a quality product, that's over processing. And the next one is overproduction, making too many pieces, scheduling. Your demand is 100,000, you do 150,000. That's overprocessing, and you know it. You know you're doing it. You know, sometimes it's one of those things with ERP systems where the supplier, your demand, say is 100,000, and then your marketing manager puts on there 110, and then the production control guy and planning puts on there another 10%, so it's 120. So everybody adding on these buffers that's unnecessary. That happens. And then talent. This is one that came about when lean was brought back to America, and because back in the 60s and 70s, my father was a automotive worker, and he was a line worker, a union guy. And I used to talk to him when I worked at GM, and we would talk, and he said, "Hey, they don't ask me to think. All right, leave your head at the brain." Because I would ask him, "Well, why y'all not cooperating, Dad?" And he would say, "Well, they don't ask me to think." And so he felt, and his peers felt like they wasn't respected and their input wasn't given, and that's what you don't want. You want, and then GM is not like that now, and they can't be because competition have driven them to be more open. You have to be if you want to be an excellent company. All these lead to missed business opportunities. What is Six Sigma? Six Sigma is like a toolbox. Six Sigma is a toolbox of mathematical and statistical equations. And these mathematical and statistical equations answer questions. Questions that you might have about a problem. Okay, how can we solve this problem? So, y is a function of f. That's the basis of Six Sigma. And all it means, let's simplify it. All it means is there's an outcome. There's some kind of outcome, whether it's sales or number of parts produced, that some type of activity in this equation drives this outcome. And that's all it is. So, the definition, a set of statistical techniques and tools for improving the process to manufacture or provide services at a first-time yield quality level of 99.99966%. So let's translate that to simple English. What that's saying is if you have a million parts, you make a million parts, you only want 3 to be bad. That's all Six Sigma quality is. Okay? If you remember that, you'll be okay. So if you're making 100,000 parts a year, just multiply that by 10 and say for 10 years, you can't make none but 3 parts bad. Okay? And you start putting that in your people's mindset, simplify it. So everybody has that mindset that we want to be Six Sigma quality. Now, Six Sigma also introduced belts. There's a lower belt that's called a white belt. I don't have that shown, but here's the yellow belt, green belt, black belt, and master black belt. And all they're saying that in the different belts, there's a different degree of complication and type of problem solving that these individuals that have these belts can solve. Let me give you an example. Here's a green belt problem. We go back to the y as a function of x. And in this case, y is percent of shirts sold. We sell shirts. And we want to know what's the percent of good shirts sold. So our x is number of good shirts sold that are not returned. So that's the equation. So we sold 100 shirts, say for a week, we sold 100 shirts. And We had 3 returned because they were defective. So our equation X equals 100 shirts sold minus 3 is 97. So 97 is our X. All right. So that's their number of goods sold, not returned. So Y is a function of X. So the equation for percentage is X divided by the total number sold multiplied by 100%. So we substitute the 97 into our X. We divide by 100, which is the total number of shirts sold. We multiply that by 100%, and we get 97%. So that looks like a good number because we're working at 97%. But if we look at that number from a Six Sigma perspective, impact quality, if we sold 1,000,000 shirts, that would be 30,000 shirts defective, returned. So that's why it's so important to look at quality from a Six Sigma perspective. And so when you see 90, and here's a chart that shows you parts per million, okay? So you got to be in the 99.98% and the 99.997% to be really where you want to be. So you can be at that 3 parts per million, the A+. Okay? A lot more sensitive indicator. Now let's look at an example of a black belt project. This is a project that we had for a company that was building a luxury car and SUV or luxury SUV stamping operation. And in this particular, on one of their body side operation was having tiny zinc flakes. It was like a $3 million problem. And it was doing a new launch of another model year. And nobody in the plant, experts couldn't figure out what was causing these zinc flakes. So when we went in and used different equation, one of the equations was a multiple regression analysis that we did for them. This is what the equation like. And this is the type of problem that a black belt would do, just to give you an example. And what we were able to do with what is called a design of experiment is another black belt tool that's used. We were able to get to the root cause and determine what operation, step 17 in the process, was causing zinc buildup in the stamping area. So the steel mill process in this particular operation is where forces was put on the mill material in order to give it the right strength. And if you didn't do it at the right amount, we were able to pinpoint what that amount was, what the range should be in order to make no zinc and all good parts so they can have that Six Sigma quality that they needed and didn't have to stop their production. So we were able to do, and their R&D, the steel mill R&D lab, actually verified in our lab what we found mathematically. So let's go back to the definition. You know the definition of lean, you know the definition of Six Sigma. Now, the Lean Six Sigma definition is a methodology utilizing Lean and Six Sigma that relies on a collaborative team effort to improve performance by systematically removing waste and reducing variation from all aspects of the business enterprise. So Lean Six Sigma is a vital portion of operational excellence. It what drives it and keeps it going. Okay. So what is operational excellence and the basic building blocks to operational excellence? That's what we're going to talk about next. So the definition, operational excellence is execution of the business strategy more consistently and reliable than the competition. Operational excellence is evident by results, and these results are from your customer. Okay, delighting your customer feedback. All right, if you got two companies with the same strategy, the operational excellence will have lower operational risks, have lower costs, have increased revenue, delight the customer, have evidence of a positive, high-performing culture. That's what you'll see in an operational excellent company. And the building blocks, you should start with the Shingo model. And because the Shingo model is continuous, and you'll see that. And it'll make sure your environment, and it hits every aspect. Now there's other roadmaps, but this roadmap is a really good one. And there's other models, but this one is extremely good one, exceptional one. Shingo model dimensions. Let's start. You have your guiding principles, culture, results, system, and tools. Those are the elements. So let's break down. Let's start with the guiding principles. The guiding principle and the dimensions of the guiding principle. There are three dimensions of the guiding principle. First, there's enterprise alignment, which is part of the purpose. Okay, the guiding principles, you may not have guiding principle in your company right now. You may have core values. At Johnson & Johnson, we didn't have guiding principles. We had the credo. When I was there, and they still do, they had the credo. And the credo had all these three things that you'll see, and that's typical in the guiding principle. So you got purpose, your enterprise alignment, and you have continuous improvement to impact your process. Okay, so in your core values, if you don't have something in about the process, you're missing something in your core values. And then your people, culture enablers. If you don't have anything in there that is a culture enabler in your core values or your guiding principles, you need it. And let's dig deeper, because this is where you start. So we dig deeper and look at the details of the Shingo model guiding principles. Under enterprise alignment, we have create value for your customer. So that's a must. You must have in for your purpose and your core values something that delights your customer. Okay, it's got to make your people want to delight the customer, and then you create this consistency of purpose and some kind of systematic thinking. All right, and then part of your continuous improvement in process, assuring quality at the source. All right. Make sure that's very, very important. Assuring quality at the source, along with seeking perfection, embracing scientific thinking, and then other things in your process. Okay. And then the foundation at the bottom, you got culture enabler, your people. Respect every individual. Lead with humility. You have to lead with humility. So now that we've went in a little detail for this guiding principle, knowing the purpose, process, people, and what all the principles are, now we're going to connect that and align that to our system. All right. Now, a lot of companies have core values that stand out there on their own. They want their people to work toward their core, but there's no alignment. You got to have alignment to your core, your system to that core value, and then that way it's going to drive your principles, your guiding principle. It's going to drive your culture. So now you get into the first step of driving this culture. All right, and then that's going to be aligned to your results. All right, your system and your guiding principle and your guiding principles got those customer base to delight the customer. So now the results are, and that culture is driving to delight the customer delight. And if it's not, you get information, get feedback from your customer. So if it's not delighting your customer, now you go into continuous improvement of your system. And as you continuous improve, you need to select the right tools. And that's where the Lean Six Sigma come in. You select the right tools, then that enables your system to be better and achieve a better result. Your customer, and you get confirmation. If you don't get the right confirmation, you can refine your tools and enable your system. And all this impact your culture and your behavior. Now you got a behavior pulling out the right tools and Lean Six Sigma, giving you a better result, delighting your customer, and it's continuous. See how this is a closed loop system? Awesome. That is awesome. Achieving operational excellence. And here I wanted to provide you with a list of tools and how you would use them under the define, measure, demeg, and a define. You have a define phase, a measure phase, analyze phase, improve, slice, implement phase, and control phase. So basically, you have these tool sets, and which will help you pull these operations, create your culture, and wanted to let you know a little bit more about Shingo's started uh, the Shingo Institute at Utah State University, which give out the Shingo Prize. Here are some of the recent recipients, and these are companies that have demonstrated operational excellence from a world-class perspective, and where I was privileged to see it being used and to also contribute to it, and my team contributed to it, is when I worked at Johnson & Johnson. At the time, they had 3 plants that won the Shingo Prize. I'm grateful and honored to have the opportunity to contribute, and not only that, be a part of, Johnson & Johnson at that time. So concludes our training today. I hope you learned something. Thank you very much for your time. If you want to learn more about the Shingo model, we have Shingo classes that we can provide for you online, virtually. We also can help you at your plant. We also have Lean Six Sigma classes that we offer. You can get to our website at caldwellsassociateexcel.com, or you can call me personally at 937-367-6743. I'll be glad to answer any questions. We have free consultation to make sure that we can help you or not. And we have a list of fall classes starting in August. So check out our website, and I hope you enjoyed this class today. And thank you very much for your time, and have a great day.